up to the front of the room. I'm Andy Germano, the Vice President of Americas for the Small Cell Forums. So first of all, I wanted to thank Globecomm and Brett for inviting me back again this year. Apparently my presentation was so brief last year that they invited me back. So this time I'm going to go a little bit longer than I did last year, but hopefully it'll be informative enough for you guys. So what I was going to do is just take 10 minutes each. We've got 4 of us here, and give an overview of the small cell industry, and that'll leave about 20 minutes for questions at the end. So just a quick agenda. I'm just going to go through the small cell forum. So I'm actually from here originally, so I can talk really fast now, right? It's not like you have to worry about different language barriers or being in the South. I live in Florida now, so we'll go through mine. I've got about 20 charts. It should take me about a minute or two to go through all these charts. But we saw this in Bose's presentation this morning, why small cells, and it's really the mobile internet explosion. It's all these smart devices, tablets, smartphones. It's this exponential growth in data traffic. And then the other trend that we're seeing is the move from mobile networks from outdoors to indoors. So the original challenge back in 1G, 2G timeframes was, how do you build a network that can do 70 miles an hour going down the highway? And now we're seeing about 80% of all mobile traffic is actually stationary and indoors. So how do you penetrate into a building? How do you get through a metal roof? How do you get to all these skyscrapers in Manhattan or Chicago? How do you get these broad coverage networks where you have good data experience at high data rates that LTE offers at 30 megabits for a user? So it's real simple. I mean, if I was just going to show one chart, I would just show this chart at the beginning and at the end. So the benefits of small cells, really kind of the killer value proposition, just like everybody said for decades, voice is the killer value proposition for mobility, for wireless. And now, like, who really talks anymore? It's all about texting and YouTube and everything else. But for small cells, the original key value proposition is just improved coverage. So in this country, about 20 to 30% of us have a coverage problem either at home or at work. I've jumped into Edge here in this room today, and I know at leaving the golf course I was trying to get my GPS so I could figure out how to get home, and I was in a low coverage area. So improved coverage is a key benefit. So for the small cell industry, we've shipped I don't know, around 10 million of these small cells already, and if we just looked at that value proposition for the industry, 20 to 30% of 300 million subscribers, that's a pretty good market if we just went after improved coverage. But all the activity right now is actually around greater capacity. So we talked a lot about spectrum today, and as we go into this thing, you'll see where people are using small cells not just for coverage but also for capacity. So a lot of the stuff that we talked about this morning with 700 megahertz being great, with this longer coverage, better propagation, better in-building and things like that, that's great for coverage, but it's not really going to help us with capacity. So with capacity, you could think of a situation where you might have some of these higher frequencies. I was going to ask a question this morning about this. FCC's been talking about the small cell band. It's at is it 2.6 gigahertz, 2.3, 2.6? 3.5. So it's like 100 megahertz. They're going to set it next to, what is it, MMDS, and get 150 megahertz potentially. So here you have a high frequency band where you can have indoor networks where you don't really want that range you're going to get out of 600 megahertz, 700 megahertz. So there's a lot of things we can do, a lot of interesting network models. I think what we're going to see is we're seeing some rapid build-outs today, and then there's going to be some refarming and moving around of networks as we evolve. But the benefits of small cells: improved coverage, greater capacity, spectrum efficiency. It's really a better utilization of spectrum. You're just reusing it again and again and again, as opposed to having one cell that's covering all of Long Island. We have a cell here in this building. He's got a cell next door, and you get that capacity replicated, much more frequently, and that's just better spectrum efficiency. And then some of the other things, we had a guy here this morning that was talking about location-based services. There's a lot of things you can do with small cells in terms of presence indicators. I walk into this room and I can get some map of Globecomm, some of the things that are going on around here. You can get some pinpoint applications in terms of where people are, and those are some of the benefits. So does everybody know who the Small Cell Forum is? A couple people were saying, I said, I'm Andy Germano, Small Cell Forum. They're like, what's that? So we're an industry association. We've got about 150 member companies, about 66 mobile operators globally, and about 77 vendor member companies that represent chips companies, software companies, infrastructure. You might recognize some of the names if the chart was a little bit bigger, but companies like Cisco, Ericsson, NEC, as well as startup companies, PureWave and IP Access, and a lot of different technologies all together in one place to help this overall ecosystem evolve. So we do market education, training, and we're not a standards organization, but we work very closely with 3GPP, 3GPP2. These are the guys that do GSM, CDMA, and LTE standards to ensure that small cells are well represented. And actually the global standard for small cells was first published in 2009 for both camps, both CDMA and GSM camps. So we've seen a lot of growth in small cells since the standards were published back in 2009. Small cells have been around for 10 years, but pre-standards is just difficult to grow an industry without international standardization. So when we talk about small cells, what does that mean? Somebody mentioned, I think it was Keith, talked about microcells coming out. So originally we were really focused more on femtocells, which are the SOHO, residential SOHO type of access points. But we've evolved the definition to include picocells, metrocells, microcells, and even Wi-Fi to some extent. So all these ones I'm showing here are licensed spectrum small cells, and then Wi-Fi is unlicensed spectrum, but we're doing a lot of work with the Wireless Broadband Alliance, or the WBA, to ensure that small cells and Wi-Fi work nicely together so you can get all the benefits of offload and this hotspot 2.0 where you don't have to log into a hotspot, but you can use the knowledge that you have in the mobile network to do seamless offload and seamless traffic shaping and things like that. And then we also look at 4 main segments. So some of the segments we looked at today are more on the rural side. So obviously we're focused on home, but also enterprise, urban areas. And the rural segment's an important segment as well. I know we've got some satellite guys in the room, and they're using satellite backhaul for applications like disaster recovery, and also covering areas that wasn't cost effective for macro cells previously. Urban areas, the big application there is for offload. You've got some areas where there's just a huge amount of traffic, whether it's in a high-rise building or in Times Square, in New York City, and you really need to have some pinpoint offload capability. And then enterprise, where they want to do a lot of applications to have better coverage at work. I mean, I've had guys calling me. I've been in this coverage business for a long time. We had guys, 10 years ago, oh, I would pay anything to have a good signal at work. I mean, think about it. If you're at the office, you don't want to miss, a phone call on your mobile phone, and having a small cell enterprise application is a key way to satisfy that. So we look at small cells in terms of the femto, pico, metro, micro, but we also look at the overlap. How do small cells work better with macro cells for interference mitigation, interference management, handoffs? How do we work with Wi-Fi, distributed antenna systems, as well as Cloud RAN? And then we also look at it in terms of use cases. So the femtocell is generally user deployed. There's a power plug, an Ethernet plug. You're done. Self-organizing network capability. As you move up in the chain, it's a little bit more operator deployed or enterprise deployed. And then looking at the small cell forum, we have a lot of different working groups. So if you're a marketing guy, you're really just interested in selling networks and network services, there's a marketing working group. We also have more technical working groups that look at the radio and physical layer, the core network capability. We even have a regulatory group that will help with different regulatory issues, whether it's in Japan or the US or in the UK, European Commission, things like that. I'm actually the chair of the services working group, where we're looking at applications, APIs, software, some of these over-the-top things you can do with small cells. And then we've got a number of other special interest groups from LTE, rural, 3GPP2, backhaul, and a new one we just started was deployment working group. So we've got tons of white papers on the website, smallcellforum.org. There's probably close to 40 white papers. So if you're interested in small cells, they're all freely available. Go up there and download. We started out with a release program. So earlier this year we announced residential. Later this year we'll be coming out with enterprise, and then next year metro, so that all these white papers are in buckets. So if you're interested in enterprise, you can just go there and get all the papers that are associated with that area. Some of the work in progress, we have an operator working group. So we just published our second set of operator requirements. So we're very much operator driven. We've got an 80-page paper on backhaul. So when you look at small cells, somebody just mentioned about fiber optics and having connectivity. There's a lot of backhaul. When you have a lot more cells, you have a lot more backhaul. So we looked at all the different types of backhaul, licensed, unlicensed, 6 gigahertz, 60 gigahertz, DSL, fiber. We also have different work going on in some of these other areas, security. We have an IOP group that does PlugFest. Different vendors can get together and test the gear out, and some of these other areas. This is kind of tying in with this morning. So over the history of wireless, the most gain in capacity has come from frequency reuse, which is basically what we're doing with small cells. So 1,600 times increase in capacity has come from reusing the spectrum again and again. So we talk about, oh, let's make more spectrum available. Okay, so you're going to have twice as much spectrum, you get twice as much capacity. It's real simple. And then we've also seen some gains from different coding techniques, like moving from 3G WCDMA to LTE. Maybe getting a 2.5 times gain with that technology evolution. And the guys that just were up here will tell you how much work it is for them to evolve from one technology to another like that. So yeah, frequency reuse historically has been a great way. And this other curve on the other side where we're showing the two lines, so where are we? If you're a scientist or a physicist, most of us on the radio side still subscribe to Shannon's theorem. So this tells us how many bits per hertz are possible. And you can see we're actually pretty close to the limit with LTE. And with LTE Advanced, we're going to get even a little bit closer. So, based on current physics today, there's not that much room to go with new coding techniques. I know there's a lot of talk now in the news in the last couple of months about 5G, but we're still talking about bits per hertz. I think from what I read in the Samsung paper is it's a lot more spectrum that they're using to get a lot more bits out of the network. But if you look at bits per hertz on the finite amount of spectrum, we're pretty close to the theoretical limit. So unless we get some kind of Einsteinian evolution here, we're kind of constrained without frequency reuse. And this is a similar, more of a radio technical chart. But you can see in a macrocell geometry where everybody's sharing the same spectrum, you're going to operate right about here, between 5 and 10 megabits per second. Whereas with a small cell type of a geometry, you're closer in the 35 to 40 megabits per second type of a service. So like we talked about earlier, with very few customers on the macro cell, everybody's happy. But as you load up that network, as you get more and more successful, suddenly everybody's data rate goes down to a lower level. By using small cells, you can offload traffic. And we've got a paper that shows with 4 small cells in a macro cell, we can offload 50% of the traffic. And what that does is it increases the user experience for everybody in the macro cell by over 200%. So very strategic use of small cells, not just for coverage, but also for capacity in offloading. So this presentation is about LTE small cells. So I just want to point out that within the standards for LTE, there's 3 different architectures that are possible. So you can have an architecture where there's no gateway, because LTE is all IP, flat IP network. You can have an architecture that has a gateway that aggregates all the traffic, or a gateway for the control traffic only. So normally in standards there's one method, but this is one of those cases where the only issue with standards is there's just too many of them. So we've got 3 architectural options. You'll have to select which one that you want, and originally there were 5, so it's better than 5. Some of the events we have coming up, if you want to join me in Paris, I'll be there next month. And then the next closest one is in Dallas, first week of December. We have an event that's coupled with a conference. But all of you are welcome to join. It's an open international organization. And with that, I'd like to turn it over to Ericsson. It's going to provide their overview of the small cell industry and what they're doing there. Thank you.
Yeah, that's fine. Let's go to the next one. So as he said, and I think everyone realizes that as we are growing up, the throughput requirements and the load on the network is going exponentially higher, right? So where 2013 we were probably around 1 megabits per second, about 2018 the data rate per user expected to be that what they're looking to get is at least more than 10 megabits per second. So it's increasing exponentially. Urbanization, more data devices, there's nearly about 4 times the data volume per device as far as expectation is. So on an average today, If I look at AT&T's iPhone, it's about 600 to 800 meg a month, going down, and that's how they actually have their data limits too, right? So 2 gig limit is basically 95% of their subscriber base is going to be below that cap. But it's going up, so they were increased it to 3 gig. Expectation is in the next 3 to 4 years, it's going to go up to about an average of about 2 gig to 2.5 gig. Let's go. So, what does Ericsson believe? I think Ericsson still thinks that there is multiple solutions for an overall network. So you have the rural network, where we think that we should actually improve our macro deployments, which essentially means go to better technology, go from 2G to 3G to HSPA to LTE, 4x4 LTE, so on and so forth. So that is one way of improving your technology. Then as we come closer to suburban areas where you'll need added capacity, the first thing to do would be is densify your network, which is the same thing as Andy is saying, is that you actually have higher frequency reuse. So you make the cell size smaller, you do cell splitting, but basically essentially densify the network, improve the network. And then you have the urban and the dense urban. Then you have problems about in-building coverage. That's where you actually add small cells, which makes, because this is really important to understand, that it's extremely important that the small cells work in harmony with the macro cells. Otherwise, you only create interference zones. So it's extremely important that that happens. And in Ericsson's view, as small cells, Wi-Fi is another technology, radio technology, period. Now, it just happens to be in non-owned spectrum or basically public use spectrum, but in our view, it is very much like another radio technology, which means that the user experience needs to be such that it doesn't matter from the user's perspective whether he's on 3G or Wi-Fi, as long as he gets good user experience. And that is what I think the next slide is what we call as one network. So the network has to behave holistically. So you have to have whether you're on the macro station, you're on the picocell base station, you're in like a micro base station, or you're on the Wi-Fi base station. It doesn't matter. You can have multiple ways of coming back. Small cells will probably still require things like VHDL, things like ADSL as the backhaul. On the macro units, you have small cells that could be connected to a main unit that's close by, and they are basically enabling handoffs that are transparent to each other. And then obviously you have your macro base stations all working as one network. So today, if I look at my UE device, I see symbols like 2G, 3G, 4G, they call it LTE, and then a Wi-Fi. But as a user, you really don't care whether you're in 2G, 3G, or 4G. What you care is, what is my performance? And that is what we are trying to really do. That's good answer. So how is that going to be enabled? First of all, you have to have this one network concept. But on top of that, you need to have control. You need to have the right systems that are going to provide the network control access selection, right? So I can be in a very busy macro network, but I have a really good Wi-Fi network available to me. Most of the people don't use their Wi-Fi network because it's a pain to turn it on and then select an SSID. But then if I have a Wi-Fi controller, that's going to completely provide that access to the Wi-Fi network transparently, so the user doesn't know. All the user knows is, I'm getting about 5 meg or 10 megabits per second download. And that's all everyone's interested in. So it's the thing, right? Make it simple, make it stupid, and it works. So the bottom line is, basically, there are different solutions depending on the problem space. At the end of the day, depending on whether it's in-building coverage, depending on its what I call as hotspots, you can have small cells, you can have pico deployments, or you can have Wi-Fi, ultimately all provided with managed services and with effective management systems behind so that you can actually be transparent to the customer. One thing that I did want to push out here, everyone thinks, like equipment costs us, it's very expensive. But if you look at a normal deployment, 44% of your OpEx charges are transport, backhaul. Another 24% are site rentals. So if I add these two, that's about 68% of your cost, CapEx and OpEx, is not in equipment, not in civils, not in RAN equipment. It's the backhaul and it's the OpEx parts. So that's why the small cells, to quite an extent, has to be very prudently deployed. You have to be very prudent as to where you're going to deploy it, how you're going to deploy it, and make sure that there's a business case behind it. Let's go to the next one. So this is the last slide, promise. So this basically shows when I said improve your technology. Improve your technology by things like what we have, air integrated radio, which basically means my radio is integrated into the antenna, which reduces the losses, and especially it reduces the losses on the uplink, which is very tough to do. I reduce depending, I can actually have a delta between a main remote and an air of about 1.2 dB. How difficult it is to get 1.2 dB on the reverse link. It's impossible. You can't. So those are the kind of things. Then, if you look at our smaller RBSs, small cells, they're integrated, pre-integrated with Wi-Fi. Because, as I said, we believe Wi-Fi is just another radio technology. Goes back, we have all the products on the back side. At the end of the day, on LTE, what you do have, you have multiple concepts as to how you can reduce interference and how you can maximize throughput. Macro cells, and study after study after study has shown, is the best technology for downlink. It might not be the best for uplink because that's at the cell edge, that's usually what the problem is. But now if you have a small cell and you use your device uses a small cell for uplink, but large cell for macro cell for downlink, which is basically called combined throughput, right? And that one will give you the best of both worlds. But those are some of the things that are being talked in LTE, and that's going to be part of Release 11. I think that should be it.
Great, thank you. Thank you very much.
Tell you a little bit about what we do and then some of the solutions, which touch on a lot of things that have been discussed throughout the day. We build wireless infrastructure, but our specific focus is to create solutions for places that you don't have good cellular coverage today. Cellular's been around a while now, and we've got coverage in a lot of places. And every operator would really like to take in the magic marker and color in the whole map and be done. So you got to ask the question, why doesn't that happen? And the answer is that the technology we have to build networks today doesn't make it cost effective to provide coverage in a lot of different places. We've talked about a lot of them, inside of buildings, in tunnels, on ships, in most rural areas. So our focus as a company is to create technical innovation to find solutions that make coverage cost effective in many of these areas. And I totally agree with the point made in the last presentation. It's really not about the CapEx anymore. The technical innovation has to reduce your OpEx so that you can run the network in a profitable manner going forward. So quick history, we were founded in 1998. We were originally, for the first 6 years, we did defense work, and then started our first rural deployment, which we did along with one of Carrie Bennett's clients in Texas from Midtech Cellular. Since then, we have a number of rural customers across the globe, US, Canada, Nepal, most recently Zambia, and some big customers, Vodafone and Tata Teleservices in India. So next slide, please. So I want to talk today about three coverage challenges we've identified and recently solved. The first one is the rural developing market. This is rural India, rural Africa. In the urban areas in those countries, it's pretty well covered and penetrated. You know, Mumbai and New Delhi are 95%, 97% penetrated. You get outside into the rural areas and the coverage is poor to non-existent. It's even worse in Africa. And so why is it? The problems they have. Well, there's no power grid. It's kind of hard to run a cellular network, traditional network, without a power grid. There's no telecom infrastructure. There's no wireline. To give you an idea, India, depending on whose numbers you believe, probably has about 700 million cell phones today. There's 30 million landlines in the whole country. That means before cellular came in, only 30 million out of 1 billion people had connectivity. So you can't rely on the telecom infrastructure for backhaul, control, et cetera. You don't have much skilled labor out there to install and maintain sophisticated cellular systems. And you've got very, very, very low ARPU. I mean, overall, Indian ARPU is below $6. It's probably a couple bucks in the rural areas. So that was one set of challenges, and I'll tell you the solution we have there. The second one actually was brought to us by one of our big Indian carriers. And it really was an emerging market capacity problem. You know, extreme subscriber density in places like New Delhi and Mumbai. And one of the interesting things about the developing market is it is and remains heavily 2G. Our customer has a 3G network. 2% of their subscribers are 3G. There's just no adoption and uptake. There's a variety of reasons between pricing plans, phone costs, battery life, et cetera. But there's really not much adoption, and it's a heavy voice and text market, so 2G works great. So a lot of the Indian regulators in particular took an opposite approach of what they did here. They wanted lots and lots of competition. They originally licensed 12 nationwide operators. So guess what? Each one has very little spectrum. Most of our customers there only have 4.5 megahertz of GSM spectrum. One of them has 80 million subscribers, and the other has 120 million subscribers. If you talk to AT&T, they'll tell you it's impossible to build a network on 4.5 megahertz of spectrum. But they managed to do it. And GSM is well over 90% of the market share. So the big challenge is they got a capacity problem, a coverage problem, and the in-building problem is really bad because most of the construction is sort of steel-reinforced concrete buildings. And it's really tough to get coverage in there. So I'll tell you about the solution we created there. And the third challenge is actually what I'll call deep rural US coverage. You know, we've got 98% of the population covered here, 60, 70% of the land area. We've got the major carriers, we've got a lot of rural carriers, and then we've got a lot of area beyond that where we don't have coverage. So we looked at that, and I'll tell you a little bit about how we attacked that problem. So first one, rural developing market. So we had to address the problems of power, no telecom infrastructure, lack of skilled labor, and low ARPU. So we developed this box. It's a full 2TRX GSM base station. It weighs less than 4 kilograms. It's 11 by 4 by 9 inches. Key is it runs up to 55 degrees C with no cooling or no sun shield or anything like that, which is critical to put out in these rural areas. It consumes only 50 watts of power. It's 2 TRXs at 5 watts each or 1 at 10 watts. And at 50 watts, you can run the thing off solar. Our first deployment here was in rural Zambia, in an area where they have no power grid or no communications whatsoever. You put up a solar panel, a few batteries with it, and you've got an operating cell system. The backhaul is probably the bigger challenge since there's nothing there. Our solution there was we've got to be able to use whatever's there. And it might be a low bandwidth network, it might be a high latency, high jitter network. So we've developed some technology, we've patented technology in securely using shared networks for backhaul. And this allows us to use a variety of networks. We've connected through, of course, traditional things, but also cable, DSL, satellite, microwave, WiMAX. We can plug in basically to any IP network. It can be shared. It can even be shared as a public network, and we can run securely over that as backhaul. So it allows us to use whatever's available or put something up like a WiMAX network point to point if you need it for backhaul in a cost-effective manner. And actually looking at some of the rural areas in Africa, et cetera, satellite's starting to become a viable option. I'm actually interested to hear what Steve has to say about that next. So this was our solution for the rural developing market. It's a full GSM base station. Just as a reference point, even in moderate volumes, it's about $5,000. So it's affordable to go into those areas. And when you take off the power, the tower from the OpEx, it becomes very affordable. It's just the backhaul. So the second one was the in-building challenge in Delhi and Mumbai, and in particular for GSM where they were spectrum constrained. Now femtocells didn't cut it. They weren't enough bandwidth. There are real problems in synchronizing handover in and out of the building. So what we took all our software from our GSM base station and skinned it down into something that basically looks like a Wi-Fi access point. But it's a full GSM base station using all the standard AA-BIS interfaces, just power and Ethernet. It is, it's a full base station, so it's frequency planned into the network, like all the other base stations. So you're not creating those interference zones. It's very interesting. Different carriers are different. The first carrier we deployed with, they wanted statically frequency planned. They wanted to control every one. The second one said, well, we're going to deploy so many of these we can't. So it actually has a self-organizing network mode where it senses, and just like is done in 3G, but this is for 2G, senses all the surrounding base stations for your network and self-configures itself and the other ones into it dynamically. It runs a secure end-to-end protocol. So we just plug into the power in the enterprise and the Ethernet in the enterprise, securely run the backhaul over it. So we actually market this as a zero OpEx solution for in-building coverage. This is just an example of one of the buildings we did in, I think this was Hyderabad. This was the in-building coverage before we deployed. This was with just one of the units in the building. So you can actually get one good coverage with one unit on a decent sized floor plate. This was, I think, is 75 by 65. If you want more capacity, obviously you deploy more. We typically deploy about 2 or 3 a floor for coverage and capacity in typical office buildings. Installation takes a day for an entire 10-story building. We pre-plan it, you go in, you secure them, plug them into the Ethernet and power, and you're done. Next slide. So the third problem was deep rural coverage in the US. Now it quickly became apparent, even if I could build a base station that cost $0, if AT&T deployed it, they'd lose money every day, paying OpEx on the site where it doesn't balance the revenue from a very, very low population density area. So the question is, how do you get the OpEx low enough? And to do this, we had to combine technology with a different business model. So we've started a separate entity called Coverage Co. And there's 3 key differences here that lead to a 10x improvement in rural network economics. First is, it's a wholesale carrier. I don't believe the world needs another retail carrier. We've got enough of them. What we need is better coverage for most of the carriers, especially in these areas. Now, it's interesting that if you look at a pure wholesale business, you have no retail, you have no phone subsidies, you have no retail support, et cetera. Your billing is greatly simplified. It's a roaming clearinghouse. You get about a 2x cost savings per site on overhead in the business than you do by being a retail operator. The second was, especially here in the US, if you have very few people, you've got to pull revenue out from every single handset that's there regardless of technology. So we're deploying a multi-standard network so we can get the GSM-based guys and the CDMA-based guys with all of their revenue to begin with. But a single network supporting multiple standards, and that basically, given that we have an even split between the CDMA-based guys and the GSM-based guys in this country, gives about a 2x increase in revenue than you would get from building a single standard network. And then the biggest one is really transforming the operating costs through the network architecture. Some of you may know Barry West. He was the CTO of Nextel and then Sprint Nextel. And he's now the chairman of Coverage Co. And a lot of this actually came from him. I guess in full disclosure, I should say the Coverage Co. business plan started over a bottle of scotch on his rural New Hampshire back porch. And Barry said, I've built tons of rural sites at Sprint and Nextel. And the traditional approach is, hey, you've got very few people, so build the tallest, highest power site you can to cover the biggest area and the most people. Barry's comment was, mostly what you cover is more rocks and trees, and they don't generate enough revenue. And he said, there's got to be a better way. So we set a goal of saying, instead of just covering the area, let's cover where people live, work, and commute. I think most of your customers would be happy if they had coverage everywhere that they lived, worked, and commuted. And in rural areas, and this is true in India as it is in Vermont, where we're building now, if you cover the roads, not the highways, but secondary, tertiary roads, and a mile on either side of the road, you get most of the places people live, work, and commute. So that led us to an architecture which is, it just sounds crazy, to be honest. We're building a rural network, rural Vermont, with lousy terrain, as 100% small cells. No high sites. What we're doing, we're taking that low-cost system that we originally developed for Africa. We created a GSM CDMA version. Next year, we'll upgrade it to GSM CDMA LTE. Our plan is to be 2G, 4G, and hopefully skip 3G. The jury's a little out on that, but I think enough momentum will come together and all the pieces with LTE roaming, et cetera, that by next year we'll be able to pull that off. So we're building on the roads, and we can actually afford to put one of these every mile on a telephone pole. And what that means is I get very good coverage even in bad terrain areas like Vermont. And the interesting thing is the OpEx. So I wish I had your chart up here with the different pieces. So I think site lease is obviously a big one. You can pay $1,500 to American Tower for a site lease every month. My site lease is $60 a year to the Vermont power company to get on the pole. Power, well, it's a 50-watt unit. That's actually below the minimum metering rate, so we pay a flat rate of $17 a month to the power company to have it on the pole. And then backhaul, using our patented secure shared network technology, we connect to whatever we can get on the pole. In many cases, it's a cable modem. I get business class service, 5 megabits up and down. I can get multiple of those connections if I want higher bandwidth. We've done DSL, we've done microwave. In some of the remote areas, we're looking at satellite, and as well as things like line of sight, microwave, and other things like that. But my average backhaul cost is about $150 a month. So for $300 a month, I can run a telephone pole site. I can put one every mile on the road and cover where everyone lives, works, and commutes in these areas where they have no coverage today. So we're up and live in Vermont now with our first 20 sites. We're in the process of building 180. So that equates basically to 180 road miles. And we are very, we operate under a spectrum lease from one of our roaming partners. And we're actually very interested in partnering more with the rural carriers in these areas to use their spectrum rather than the big operator spectrum. I think it could be a win-win for everyone. So we're quite hopeful that we can get, with this model, good, profitable coverage down to areas, and this is a hope and it's not proven yet, down to areas of 10 pops per square mile, that we can still be very profitable. So we're building in some of those areas now, and we'll see how it turns out. This is actually one of the sites in Vermont. I just want to show you because it looks kind of crazy. yeah, it installed in the snow even, it wasn't a big deal. There's an antenna now. We're not actually in the power space. We're in the comm space, which is below the power space. So we're at about 30 feet. And that's because if you're in the power space, it complicates everything. You got to get union labor. You only have certain windows to get out there. You have to coordinate with the power company. In the comm space, I hire an electrician for $15 an hour, and he can go and tack it up, no problem. Now, if you look at this box here, there's two boxes. See the little box on the side? That's actually the base station. The big box has the batteries. So we're at the point where the base station's smaller than the batteries. And if you don't care about battery backup, then you can have a really, really small site. Just mounts on the pole. I think Vermont loves it because we're not building big, ugly towers. My marketing slogan is, this is less ugly than things that are already on the pole. So it's not so bad. And we can put up, you get a guy with a bucket truck, and you can go up and put 30 of these in a day on a road very, very easily. So, and one of the other things, since the install's so low, if you screw up, you just move it. It's not like screwing up building a high site, right? So a lot of times we're able to put up stuff and look at traffic and coverage, and if we don't like it, we can move it. So it allows you to really adapt the network very, very quickly. So it's a very different model. It allows you to do a small, so it's a different take on small cells. It's small cell for outdoor rural coverage, which sounds counterintuitive, but if you really attack the OpEx like we did, it becomes very feasible. So in summary, You know, we focus on trying to create solutions for places where coverage is difficult or not cost effective today. If you got one of those problems, come talk to me. Maybe we can figure out a solution. Thank you.
Thanks.
I think everybody touched on backhaul. I guess the two key themes of what I want to talk about is that Vanu mentioned in his thing, kind of the and theory. I mean, there is no one answer. We're going to use an awful lot of things to solve this problem. The architecture is changing dramatically, yet the industry is all set up to support the old architecture. So a lot of change coming in the future, and I think it all is driven by what the expectations are. So the main thing that I focus on, and it's kind of a Globecomm focus, is universal service. You know, we generally are not doing a lot of work where the mainstream of things are going, because that's very productized. And we're generally trying to solve the problem in those places where it's more difficult to solve. And but the big thing that's driving everything nowadays is that people expect that experience that they're getting in their homes and in the main cities everywhere. So if I'm getting 2 megabits at home, I expect that when I go out to a resort, I'm getting 2 megabits. And if I go to some rural county, I'm getting 2 megabits, and that's far from true. I know that when I travel, a lot of times my choice of hotel is based on my experience in my broadband. How effectively can I work where I am when I get there? And you know, Vanu is doing it, and we've done it with Vanu in some applications. Multiple technologies required to solve the problem. You can't focus on one technology and assume it's going to solve all problems. You have to really have a broad mind for the solution set. The big thing that's changing in the mobile and wireless broadband world is the concept of high cell density. That's a kind of a big change, and it really changes the backhaul scenario. Now, instead of the obvious answer of running a fiber to a big boomer tower, I could have 200 small sites that I'm trying to get 70 megabits or 100 megabits apiece to, and that may not be very effective, particularly, let's say, if I'm in an old city or a new rural town where the acquisition and protection of right-of-way, in the old rural, like in Africa, the protection of right-of-way is impossible. In New York City, the acquisition of right-of-way is impossible. So it becomes very difficult. There can be wireless answers. I've never challenged the cost per incremental bit in the fiber system. It's the least expensive way you can go, but a lot of times it cannot be practical. And there's many new solutions, and there's a lot of things changing because people are seeing this, and you know, wonderful capitalist society is trying to find every way they can to solve the problem. Give me the next slide. I got to go pretty quick too for you. So I just talked about the toolkit from Globecomm's perspective. There's fiber, and fiber solves a lot of problems. A lot of times, big trunking fiber goes running by a town that it can't serve, though, because the town is too small, and other problems that we face. And we've got a number of programs that try to solve that problem. And so if you can't use fiber to the home off your trunking fiber to serve everybody, then you start looking at wireless solutions, and there's a broad scope of wireless solutions. You know, point-to-point to multi-point, high frequency, things that are line of sight, non-line of sight. One of the technologies we're playing with right now, and we have Cheyenne in the room from Blue One, is working in the MTVDS space and what they call fiber through the air to create super high densities, multiple gigabits per cell, which we can use to deliver broadband, and then cognitive systems that operate kind of, to me, it's like electromagnetic warfare in the commercial space. I mean, you really can try to operate in unlicensed frequencies or licensed frequencies, but get much higher performance in a highly interfered environment. In the satellite world, that's changing dramatically too. It's specialized satellites that are much more powerful and more specialized and can reach much higher, much lower price points for delivering bandwidth. Nobody's focused on delivering bandwidth to cell sites, but I think if you did, the numbers would be amazing with the price you can hit, and I'm going to talk to that briefly. Next thing. This is just something I pulled from, I should be able to quote it properly, but I think it was from Loral Space, but it shows the cost, and I added a couple things to it, right down at the end, that fiber to the home should really be fiber through the air. I came up with the price, the cost in dollars to deliver a gigabit per second. The capital cost in dollars to deliver gigabits per second. It's a funny number, but what's interesting about it is how dramatically it's declined over the last, you figure Spacewave maybe 10 years old, over the last 10 years. I mean, it's really, really coming down. Next slide. I said, okay, let's go worst case. I'm going to go with what's available today, and I'm going to serve a single cell with broadband services, right? I'm going to have at least 50 megabits to that cell support, 100 megabits if I want it. What can I buy today? In Europe, I can buy that for $3.50 a gigabyte. So I didn't know this, but I figured somebody at Ericsson knew the answer, and you put it up on the chart. I'm figuring typically my backhaul is, I thought 25 to 50%. We said 44%. So $7 a gigabyte, kind of an expensive number. But I also looked and found that the average price paid in that market per gigabyte at a cell phone is the range of price is 65 cents to $13 per gigabyte. So why $3.50 is an expensive gigabyte? I asked myself, in some applications, high-end gated community, right? The island of Mustique, private island in the Caribbean, where I can't even tell you what the rents would be in a place. People might pay $3.50 a gigabyte to have 10 megabit per second types of services in their abode, right? If I tried to create that off of standard KU band systems today and just optimized it for this application, I come up with a number about $4 a gigabit. And I'm convinced, although I couldn't convince you here today, I couldn't go through enough math, that I could get the 50 cents a gigabyte if I just designed the system to serve the hardest to serve cell sites. And if I took the United States of America and said, okay, I'm going to create a system to serve 500,000 hardest to reach cell sites, I'm convinced I could get to those cell sites for 50 cents a gigabyte or less, delivered, you know. Would that be a business model? I don't know that answer. I mean, it really was fun to be here because the people in this audience know that answer better than I do. But in my opinion, at 50 cents a gigabyte, if I go anywhere I wanted to and round out my coverage, I don't know if we have any Indigo guys in the audience right now, but you know, if you could hit if you could buy from a wholesale provider, right, a wholesale network provider, so Vanu and I cross paths in a lot of ways. A wholesale service provider is going to serve your most remote network. Actually, that's a business plan for Coverage Co. I didn't think about that. Going to serve your most difficult to reach sites. I'm going to go to all carriers. And I'm going to say, give me your 500,000 most difficult to reach sites. I'm going to reach them for 50 cents a gigabyte. Is that a business model? Okay, could be. I don't know that answer, but I think it might be. Right. Next slide. So the big issue, yeah, is what is broadband? I think it's like 2 to 10 megabits per second today. I'm not sure because I'm not the right guy to answer that question. What are customers willing to pay? I've looked around and I see that people pay from 65 cents to $13 a gigabyte. And a big question if I were to develop this system is what's the price point? What are people willing to pay? What percentage of the cost should be the bandwidth? We generally look at ourselves as solution providers, but when it comes to the cellular part of the solution, I'm generally working with Ericsson or Vanu or somebody who's solving that element of the problem, and I'm looking at the overall network problems associated with it. And the biggest issue is all this demand and changes in scenarios is changing technology. There's a lot of new entrepreneurs out there that are really running and gunning, trying to find the answer to all these niche little questions. And again, I keep coming back to the and solution. The solution is how do you find all those little answers, put them together in one complex network that solves the problem. Oh, and this was just so here's a concept here. I put this together. We are doing a network now in Somaliland that takes advantage of a major fiber run. The problem the fiber operator had was that when he decided he got the right to build exclusively fiber in the country for like 25 years. His only customers are 3 cellular operators who can collude against him and set the price point. So he's got a problem in trying to monetize his network. So he wanted to have a way of creating a direct access service off his fiber, so he had another way to sell. And okay, so this is just a quick thing that shows you from fiber, I can distribute directly by LTE. I can distribute fiber to the home. Next slide, I'm going to go quick because I'm being told. I can also create these cells that we're talking about, the fiber through the air, 100 gigabits per second in a cell, sectorize it up, and serve individual businesses with 100 megabits, homes with 10 to 100 megabits. I can serve individual LTE cells inside that with 100 megabits apiece and have them distribute to the end customer. I could use new radio technologies that basically use cognitive techniques to assemble all the possible paths between 2 points and create extended range and bandwidth to extend off these sites and then distribute with LTE. And I can hit people directly by satellite using a whole series of geo. You got O3B, new satellite systems haven't been invented yet, different applications of Jupiter, Viasat. So there's a lot of ways to solve the problem. And I think if you want the universal service, you use them all. Okay, thank you very much.
So three really excellent presentations. We heard on the backhaul, we heard radio access network, and we heard on the infrastructure as well as new technologies around small cells and working with macro cells for different applications. So any questions from the audience? You guys have any? There's got to be some questions. Some really cool stuff here. Go ahead.
What did you say the price of a small base station was, approximately?
The one for Africa, that was $5,000.
$5,000.
In moderate volume, like 20.
And have you considered embedding Wi-Fi functionality in it?
That's coming in the next version.
Same thing for Vanu. In your coverage co-model, who's the operator?
Define operator in this context.
No, you define it. I mean, what I'm asking is who is coverage co?
Coverage co is a wholesale network operator. So they have no subscribers.
Right.
They provide coverage. Their customers are carriers. So we have roaming agreements with Sprint and T-Mobile and Bell Canada, et cetera.
So in addition to
and
coverage,
the core is actually run by GSI.
in addition to coverage co, aren't there other independent licensees that are also doing roaming and also operating with subscribers in the same territory?
No, our goal is to build where there's no coverage. So we're building where there is zero coverage.
Okay, so
occasionally there might be some fringe coverage from one operator, but it's not very good.
I see. So you're filling in the Swiss cheese.
Exactly. And because we don't have retail subs and we're wholesale, we can do the Swiss cheese model. Contiguous coverage doesn't matter to us. We can fill in the holes. We're looking at Vermont. Next, we're going to do North Carolina, and we're looking at some other states. So we're really filling in the holes for everyone else.
If the OpEx savings is great in your technology and it's easier to deploy, isn't it profitable and very impactful, not just to the holes, but there are some edges of the network that is very unprofitable for the carriers anyway. They really ought to have some network sharing or have a wholesale model, not just in the holes, but at the edge of their networks as well.
Quite possibly. I mean, we've actually had some of those discussions with some of our carrier customers. We're starting by going into the holes. And then, you know, every carrier has about 10 or 15% of their sites that don't make money at the edge. And we could sort of move into that territory. The basic, you know, where we are as a company right now, we just got the first 20 sites up and running. We're going to deploy LTE next year. I think we get to next year and we see that on 2G and 4G, the customer experience is good, then we absolutely would have that discussion is open. But I think, you know, we're proving ourselves in the area where nobody is. And then where it goes from there, we'll see. But it's a good point. I mean, we know that one of our customers actually has 15% of their sites at the edge that they lose money on every day.
Yeah.
So we may be able to help with that.
Is out of U.S. a similar whole strategy or a different kind of a partnership opportunity with the incumbents, isn't it?
Yeah, there's a couple things that make this really good in the U.S., and it's because of some of the FCC rulings. So, for example, secondary markets, we have a lease for 20 megahertz and 1900 megahertz spectrum in Vermont. A lot of countries don't allow that. The roaming, the fact that you know, in some countries they still have the rules like we used to have that the spectrum owner has to own and operate the transmitting equipment. So a lot of things have been liberalized here that made a true neutral host wholesale operator feasible. Those are coming in places like India and Africa, and we are certainly looking at that. But also, the advantage to this model as opposed to partnering with a particular operator is that what you end up doing is bringing true competition to the rural area, because they can have multiple, like here, Sprint and T-Mobile are offering their same nationwide pricing plans in the area we cover to those subscribers. Whereas a lot of times in rural Africa, you partner with one carrier, and it's not a very good deal for the customers. So the fact that you can be technology or carrier neutral is something that's viewed positively by the regulators in those countries. So I think it will happen, but the rules have to change.
In the beginning, you said you're covering where there is no coverage at the moment.
Correct.
And you mentioned roads, tunnels, and buildings. Are you doing the last two as well?
In India, we're doing the buildings, okay, inside of the buildings, and that's not necessarily where there's very, very poor coverage, right, and inside the buildings. We haven't done anything on tunnels. We're looking at chips right now. Yeah.
We have a question in the back.
Just one quick question. You mentioned every mile putting up a repeater in Vermont.
It's not a repeater. It's a full base station.
Base station.
Mile.
I'm sorry.
Yeah.
How many miles of rural road are there in Vermont?
The subset of the question that's relevant is how many miles of roadway are there where there's no cellular coverage, and we've done this. I think it was like 1,500. If we covered everything in rural Vermont that didn't have coverage on the roads. Our initial build plan is only 180 of that.
I'm sorry, this is the second time I've heard Vanu speak in the last 10 years. I hear him speak a lot, but on a different issue where he appears to be the white knight ready to save the rural industry. So this is the second time you're being a white knight, and I have to ask you, are you going to go after Mobility Fund Phase 2 money? Because you seem like you're primo set up to go after the road miles of these unserved areas throughout the country, and you have a really low-cost solution. So are you going to do that?
We need to look at that, need to talk about that. The road mile thing is a good fit. In the past, I will say we ran into trouble with some of these federal subsidies for rural, particularly with the stimulus funds or the old RUS rules, where you're getting a subsidy per subscriber. Well, we have 0 subscribers. So it's a problem. So now it's road miles. I agree. That's a huge plus and change for us. So yeah, we definitely are looking at that. Thank you.